Today we will solve a dungeon game problem. It's a very interesting problem. Here you are given a grid. It's a dungeon, and here in each cell either you get some reward or you get some devil waiting out for you. So if you get a reward, your health increases, and if you face an evil or some adverse situation like fire or other things, your health decreases. There may be some empty cells also where health is not impacted at all. So there is a knight and there is a princess. So princess is captured here in the bottom right corner, and this is the princess, and this cell may also contain some reward or some devil or zero. So the knight has to start from here, top left corner, and the queen is at bottom right corner, queen or princess, whatever you like. So the condition is that the health of knight should always be more than 0. If the health of knight is equal to 0 or less than 0, then the knight dies. So it should be strictly more than 0. So this is the condition. So you will be given some numeric values instead of these. So for these you will get negative values. For these rewards you get positive numbers written here. So when you have a reward of, let's say, 5 here, and this is +1, then at the end of this, after reaching this, you will get 6, since this will be added. And again, if it's negative, it will be subtracted. And at no point of time it should go to 0 or less. So the question is that what should be the minimum health of the knight before starting here, before entering this dungeon? So let's look at an example, then it will be more clear. So for example, the knight will enter here and the princess is here. So let's say the knight enters with a health of 5. So the knight will come here, its health will become 3. Then it will go either here or here. If it goes here, it will become 0, so it will die. If it goes here, it will again die, it will become -2. And the direction that the knight can take is only right and down. These are the two directions. So you see that 5 was not enough. So the answer should be more than 5. So let's see how we can find that. So let's start from here. This is the destination. So the knight can reach here either from this one or this one. There is only two choices. Either this is the second last cell or this is the second last. Whatever is the cell, for entering this, before entering this, the knight should have a health of +6. If the knight has at least health of +6, then if it reaches here, its health will become 6 minus 5. Whatever was the earlier health, subtract this value, negative value. If it's positive, add that value. So it will be 1. So 1 is the bare minimum health required. So the knight should have at least 6 health, whether it's coming from this or this. So now let's assume that the knight comes from this. So for this we have the solution that if it wants to reach here from previous one, it has to have a minimum height of 6. So let's create a solution array also of the same size. So you can clearly see we are using a dynamic programming approach here, and we are solving it bottom up. So before entering into this cell, the knight should have a health of 6. Now it will enter from here or here. So let's solve all this in this last column. So for entering this, what should be the minimum health so that it can reach here? So if its health before reaching here is, let's say, 5, no matter from where it comes, then its health will become 6. And now if its health is 6, it can go here. If its health is not 6 at least, then it cannot reach here from this. So what should be the minimum health required before reaching this cell in order for it to go to this destination? So here we already have +1. So what is the extra required? 5. So it should have at least 5 while coming here, either from here or here. So minimum requirement here is 5. So if you enter this cell with a health of 5, your health will become 6, and if your health is 6, you are eligible to go here. If your health is less than that, you cannot go here. So we are keeping track of the minimum health required, so that from there you can make a progress to the destination. So now we have solved till this. So if we reach here with a health of 5, we can reach the destination successfully. Similarly, here it's already 3. So from here, what should be the minimum health required to reach here? It should be 2. So if you reach this cell with a health of 2, you can always take this route, go here, it will become 5. Then if you reach here, it will become 6. And once you have 6, you can reach here. Then it will remain +1. That is, the knight will be alive. Now let's solve for this row. So what should be the minimum health here so that you can enter here? That's 6. So you need a minimum health of 6, then only you can go here. Here you already have 30. So what is the remaining? So if you enter with a health of -24, although that's silly because your health cannot be negative, you will die. But let's say the knight's health is -24 before reaching it. So after reaching, what will be the health? -24 plus 30, that is 6. So now it can enter this one. But we will apply a cap on this, lower cap, floor on this, so that it cannot go below 1. So 1 is the floor, there is no ceiling, and then below this floor is 0, and -24 will lie somewhere here. But this is blocked by this floor, you cannot go below this. So it will be 1. So if you enter this cell with a health of 1, your health will become 31. And then you can easily go here because minimum requirement is just 6. So here it's 1. Now what should be the health here? You just need a health of 1 in order to advance, make a progress towards destination. So what is the remaining? -9, again 1, since it cannot be negative. So we are subtracting whatever is the requirement of this cell. So if we are trying to find for this cell, let's say this value is x, and when we are here, we would have already solved this part and this part, since we are going from bottom to top. So for this, you will need the minimum of these and these. We have already solved the health requirements. So whatever is the minimum health requirement, let's say this is H1 and this is H2. So what we will do, min of H1 plus H2. Since from both of these, you know what is the minimum requirement to reach the destination. So let's say from here you need just 5 health to reach the destination. From here you need 10 units of health to reach the destination. So where you will go? You will go this one. So that's why min of H1 and H2. Now what is the remaining? So we had subtracted this current value, that is x from the cell where we want to go. So min of this and this and minus x, but it can go negative, since in this case the requirement was 6 here and here we had 30. So 6 minus 30 is -24. So we will limit 1. So max of these two. If this value is more than 1, then we will pick this. If it goes below 1, we will pick 1. This is the limit that we had applied. So that's why we solved this row and this column, so that for any cell in between we have these values, and we can simply pick the minimum of these two, which we have already solved, minus the current value, and if it goes beyond below 1, we pick 1. And finally we will advance here. Let's complete this problem. So here it's 1 and 5, so we will pick 1, and 1 minus -10 is 11. So 11 and 1, which is maximum, 11. So we will pick 11. So you need at least 11 for reaching here. So once you enter with 11, your health will become plus 1 since 10 is subtracted. Then if you have 1, you can go here since the requirement here is minimum 1. So you will come here and again here your health will become 31. 30 is already lying here. So 31, then you can go here. Now let's solve this one. You need this and this, minimum is this. So 1 minus 5, that is 6. So you need 6 before entering into this. And now let's solve this. Minimum is 2. So 2 minus 3, that is 5. And here we came from this. So let's keep track of this also. This we got from this. And here we got from this. Or rather it's the opposite way. If we reach here, we go here. From this cell we will always take this path. Since the minimum of these two was 2, the requirement, minimum health required among these two is this one. So you will go here. And if you are here, you will go always here. This will not exist. And if you are here, you will always go here. And from here also you will go here. Now we need to solve this 5 and 6, which is minimum 5. So 5 minus 2, which is 7. 7 is more than 1, so pick 7, put 7 here, and we picked this one. This was the minimum, so from here we will go here. So now let's verify. The knight will come here with a health of 7. So knight outside has a health of 7. When it enters, its health become 5. Now its health is 5, and we see that it will go always this side. So its health will become 2. Then from here it will go this side. So its health will become 5. From here it will go down. So its health will become, from here it has just one path, it cannot go right, so it will go down. So its health will become 6. And from here it will again go here with a health of 6, and finally it will be left with a health of 1. So it will be alive and it will reach the princess. So you see that here we reach with a bare minimum health. So 7 was correct. Any larger value of 7 will work, but we have to find the minimum health. So that's how we will write the code for this. So let's write it in C++, Java and Python. Number of rows is dungeon.size. Number of columns is dungeon0.size. Then we keep a solution matrix exactly of the same size. So vector of int. Let's call it solution. R vectors of int, each of size C. So this is R cross C. Now we will solve for this bottom right cell. So if it's positive, then you can enter with any valid health. That is, even if you enter with a health of 1, it's fine. Your health will only increase. But if it's negative, then you should enter with 1 more than its absolute value. That is, you need at least 6 before entering this. So this is R minus 1, C minus 1. If it's greater than 0, then you need the minimum health, that is 1. Else 1 minus dungeon R minus 1, C minus 1. You can also take the absolute value and add 1 to it, but if you subtract it, it will become positive, that is absolute value, and add 1 to it. So 1 minus this. So we have solved for this. Now we will solve for a last row and last column. So let's solve for the last column. So int I equal to r minus 2. R minus 1 is the last row, but in this last column we have already solved this, so we start from this and go till top. Here column will be fixed, c minus 1. So we will add 1 for the max, so it should be at least 1, it will not go below 1. And the first one will be whatever is below it. So if the requirement here is x, here it should be x minus this value. So it's solve I is 1 minus I plus 1, that is one cell below it, and this column will remain same. Similarly, we will solve for last row. So int j equal to c minus 2, j greater than equal to 0, minus minus j, solve. Here row is constant, so its row number is r minus 1, and j is varying. And again the same logic, max of one right cell is j plus 1, minus current value, so r minus 1, j and 1, so it will not go below 1. So now we have solved for minimum requirements for these and these. Now we will start from here and go till top, solving it row wise. This row, then this row, and finally we will return this value, since the knight will enter from here. So he should know beforehand what is the minimum requirement for entering here, so that I will reach the destination alive. So here we will see what is the minimum requirement for this, and pick the minimum. So min of I plus 1j, I j plus 1, and from that subtract current value, just like this one. Only thing is that here we pick minimum, here there was just one choice. So from here you can only go down, right is not allowed. So that's why we were just bothered about this cell. Here we can go only right, not down. So here we did not need that. But here you can go in two directions. So we are taking the minimum. Every other logic remains same. Minus dungeon I j, and again we will take the max, so that it does not go below 1. And that should work. Let's return sol 0. And this matches with expected value, so submit. And the solution is accepted. So let's see the time, it's 79.75%. Let's try once more if it improves. It's pretty close to higher end, so it can easily reach. So it does not change. So what is the time complexity here? Here we have number of rows, number of columns. So we are solving for each cell. So the time complexity is of the order of r cross c. Now let's write the same thing in Java, and there is not much change in syntax here. Size becomes length. And this remains same. This becomes math.max. So the Java solution is also accepted. And here we are right in the top. Runtime is 1 millisecond. Now let's write it in Python 3. And max is valid here. Now let's so from c-2 go till 0, this is excluded, and take a step size of -1. And max is valid, max and min, so no change is required here. One if dungeon RC is greater than 0, else okay, so this out of range, that means 0 times c. So each row holds a list of size c. So let's allocate it. Now it should not be out of bounds. And this solution is also accepted. And it's also time is quite good. It's right here towards the higher end only.